Okay, hey, hello. Hope you're doing well. Gonna continue more of this OS dev here today. All right, so I wanted to implement disk saving and loading, loading reading sectors to and from the disk into memory and vice versa. I wanted to do this at a better level for a while now, so I guess I'll do it now. I'm gonna change this to take in, I guess, more formal parameters on the stack instead of just inputting things into registers, which we could do either way, but I'm going to move more towards maybe using the stack to pass around parameters to different functions, because I think it works more agnostically, I guess. Then you can use whatever registers you want, just, setting up stuff, pushing and popping. But let's change this. I'm going to rename the file, I think, as well. From disk_load, I'll rename to load file. I guess it doesn't have to be a file, it could just be data, but for the purposes of this OS going forward, we're going to say it's load file. I want to load a file from our file table, find its location on the disk, and load it into memory wherever we're using it from. Load file. Let's set up params. We're going to say parameters or parms. I guess I can put parms, right? We're going to load a file. Let's say it has a file name, so I'll put the file name, and the memory location I want to load the file to. So memory location to load file data to. And this we're going to call load file. This file will be load file. Let's change that actually. Not .include, that doesn't work. Include disk load, we're going to change to load file.inc. We got to pop the arguments off the stack in reverse order because we pushed them onto it. When we call it, we're going to assume we have the memory location second, so we're going to pop that off first. Let's assume we're going to use segment offset for this, so we'll put memory location into ESBX, but we'll pass it as 2 parms. So I'll put in here memory address for segment and 2 memory address for offset. Right, so let's pop the first one. I don't know if I can pop directly into ES, but we're going to try it. If it doesn't work, we'll pop into like AX and then move it. Okay, and then the second one we'll put into BX, so that at this rate, or well, after this, EXBX will point to our memory location. Alright, then after that, we'll say we have the file name, so I guess we'll pass an address for that and pop it into SI. SI file name. ESBX memory location. BS will be the segment address, and BX the offset address. Okay. So let's say the first thing we do is get parms. So what we have to do is search the file table for the file name we got, assuming it's in SI. Okay, so we want to search for the file name. So what is the first thing we want to do there? We need to, get the address for the file into somewhere. We do have 2 extra segments we could use. Maybe I could use FS or GS and then put something else into there and offset using that. If we want to use ESDI, then we can't use ES up here. So let's pop that into FS for now. Search the file. So the file table location is in 1000, right? According to our boot sector. Yeah, loading into 1000. So if we want to search the file table, what we can do is we can't XOR EX, but we can move 0 and then move AX into there. This we can XOR. XOR AX, so 0 out ES first. And then set some other number, I guess DI. We'll set to whatever. We'll set to the location. So DI will do 1000. Okay, and then we want to search it for the file name. Well, we already kind of did this code within the kernel, so we could look at the kernel for doing this actually. Okay, so I'll kind of do this kind of code here. Check next character. Well, we'll do check file name. That's kind of what it's doing. It's checking the next character in the file name, so we'll just call it that. Move AL. This will be ES DI. So the file name will be in SI, so we have that set up. But we want to check the file table for that file name. So if we're at the end of the file table, that will be 0 because it's petted out with nulls with 0 bytes. So this would be end of file table. And then jump equal, we'll do file not found. Otherwise, we'll compare AL to what is at SI, which SI should hold the address of the file name at this point. Start compare, or well, we'll do compare file names. Okay. We need to add 16 bytes. One word would just be 2 bytes. We don't want to do that. So let's add di 16. And then we'll jump back to check file name. Okay. Probably get rid of the stuff below. This is what we're going to do. So assuming that all works, we're good. Now if it doesn't work, then again, file not found. So I guess we would just return at this point if file is not found. We might display a message, I'm not sure. But let's just assume we're returning from this function at this point. So compare file names, what do we want to do for that? I want to push the position and then go back. So push di dot loop, we'll just make a generic loop here. Just still copying stuff, move, ESDI. Well, moving SI to AL is something. I don't think there's a string instruction for moving DI to AL. There's loading, which is SI to AL, and there's storing, which would be AL to DI, but not DI to AL. So maybe I could set file name to, nah, well, we'll just keep doing this, whatever. It's fine. It is fine. We want to do this, we want increment. Increment DI, compare AL to SI again. So not equal, we want to restart. We need to save SI then, if we're going to be changing it. Let's put it at, I'll just put it at the bottom here. Make a generic file name. File name sort of variable. Variables. How long do we want our file names to be? Right now in the file table, they're 10 characters in length, so the max this can be is 10 characters. So let's reserve 10 bytes, which I think initializes to 0. I'm not absolutely positive, but that just reserves 10 bytes. Let's do something like this. Move CX10. Copy file name to variable, I guess, or storage. Make another loop. See, the benefits of doing stuff like this, if you use the dot notation in the loop, because I don't remember if I ever explained this, you can do multiple ones of these within the same segment of memory or wherever your code's running. And they will work because these will be associated with the next global label, which I think will be this load file label. So this dot loop is considered like a local label, such that this one's associated with the last global label. And if I do another one, like under a different label here, like under compare file names, I have another dot loop. This dot loop will be associated with this compare file names label instead of the overall load file label. So instead of the assembler yelling at me, hey, there's duplicate definitions for the same thing, this will work because this just equates to an address, which is a number, but that number is kind of offset from this label position, compare file names. Whereas this loop up here will be offset from this load file label in memory. So we'll move byte at SI into, well, I don't think I can do this actually, memory to memory. I can't do that, can I? We'll see. I don't think I can do this though. That's what I want. I might have to move it. Let's change this. Load string byte. So that'll load into AL, and then we'll move AL into file name, right? We want to move into file name. That's the opposite of this. Although if it's AL, I think it knows it's a byte, so maybe I don't have to do that, but I might have to. We'll see. Now we'll move that value into there, and then we'll loop to dot loop, which will decrement CX and move on when it's done. Okay. Oh, we need to increment file name as well. To put it in the next position. Okay. Check the file name. We want to go to compare. That should be okay. Except instead of SI, we can do file name. we'll save the DI position in the file table. Okay, move it, increment, we'll compare again. At the end of this, file name has been incremented, so we probably want to decrement after this. Or we can use SI down there. Let's just reset file name. Track, this will be, I guess this will be byte. I'm not sure. Maybe we can do this. I don't know if any of this stuff is going to work. I'll probably have like 50 errors I have to take care of after this, but that's all right. That's life. I'm gonna assemble this just to fix the errors, but I'm not gonna have this be a final binary. This will be an include file to other stuff, but I will assemble it to make sure. So restart, search, restart, check. Okay, well we can do it before here. 10 is the max length, so we'll do that. 10 fits in less than 255, so it'll automatically be in CL. So we can just do decrement CL. 0 found file, otherwise we'll increment the name we're doing, so file name. And then jump .loop. Restart check. We need to reset file name if we do this. Do the same thing for SI. Make sure they both point to the same one. Or we can move SI to file name here, it doesn't matter. We can do that. SI will equal the name, sure. I need a temporary storage to hold the position of this anyway, so move SI back to there. That's okay. Well, SI will point, we can use SI for this, it'll point to it. Can reset. Let's use SI instead. We'll increment SI instead of file name. Yes, SI. Then we'll reset the position by doing this. Okay. That's probably better. Start compare, push DI, so I'll pop DI. Get that position back. Increment DI. This is jump. Check file name. Okay. So let's go to found file. I think that's what I called it, right? Yeah, found file. So if we found it, we're at the end of the name in the file table. So we want to load it to whatever memory location that was requested. File extension, we don't really care. We're just loading to a specified location. Go to starting sector number in the file table entry, add bx4. Okay. So we're doing ESDI for this, right? Yeah. Pop to the FS. So FSBX holds our stuff. ESDI is the file table entry. So the sector number would be here. So what sector number do we want to use? Well, we're using int 10 AH2, right? Which I pulled up. Int 13 AH2 rather. So AH needs to be 2. AL is the number of sectors to read. CL is the sector number to start at. So blah, blah, blah. I'm going to put this on my other monitor here. Move that into CL. We're going to set up the params now. Let's do this here. Set up params for int 13 H AH2 read disk sectors in the BIOS. Eventually I want to use something that isn't a BIOS interrupt to move better towards protected mode. And I think I'm going to go with ATA, read-write operations. ATA sectors, still using cylinder head sector addressing, but I'll do that in a bit. It probably won't be in this video because I want to get this working first, but I will eventually move towards that. ATA being, you have like your SATA drives. SATA 3 is a protocol or an interface or whatever. That's serial ATA. ATA is the OG, which I think was called parallel ATA when serial ATA came out in the early 2000s. But anyway, that's another way to access hard disks without BIOS interrupt using input and output ports. in-out instructions, so I'll do that later, but we're still using int13 ah2 to read. We'll be using ah3 to write after this. So CL, we want to move ESDI. All right, then the next one, put into BL. All right, let's reset the disk for, I don't think I have to do this, but I guess I'll do it anyway. So XOR AX, and then DX I'm not messing with yet, so DL should be fine. Move DL 0, can XOR DL as well. And 13, just reset disk 0. Read disk sectors, start reading it here, so BL, we don't have to do now, we can do AL. Well, AH has to equal 2. Alright, AL would be the starting sector and the number sectors to read. We had the second one, so this will be ESDI according to our file table entries. And wherever we want to read it, we need to set up an ESBX. Alright, we'll XOR DX for good measure. DH is the head number. DL we already XOR'd up here, but we'll do it again just in case, I suppose. DL is the drive number. And then we'll move, if we can do this, we'll move FS into ES. And BX should still point, well, we did change BX, didn't we? No. We have not used BX yet. So I think we're okay for that. So BX is fine, we already loaded that. This is segment address to load to BX already loaded. And that should be it, I think. Then we run it 13 to call the thing. If the carry was not set, then we're good. If the carry was set, we had an error. So not carry, loaded file. We'll say it was set, then we had an error. Which I don't have error handling yet. We'll just say it wasn't loaded, I guess. I don't know. And then otherwise we run the program in the kernel, but here we don't want to. Here we're just saying, hey, we loaded it, so we're good to go. So loaded file, I guess we can return regardless, right? The stuff down here I don't need. I guess I'll keep the disk error stuff here. Maybe not. We can deal with it later. Alright, handle error. Otherwise we loaded. I guess we'll do the same thing. File not found, loaded file. We'll just do end program or return. Where did I do file not found? Here. Return to caller. Okay. And we'll just return at the end. I'll put a to-do here. Doesn't mean I'll actually do the to-do, but I'll write it down and it makes me feel like I did something, right? So hopefully this is ideally how our stuff would work, to load to a given segment offset address given a file name. We're not resetting CX though, which is interesting. I don't think I did that over here. Maybe that's a bug, because we're never, if we're doing 10 at a time, and we fail checking one file name, you figure we should restart and go back to the full length of 10, but I don't know, we'll see how this works for now, I guess. We'll say this is ideally how we want to load a file. Alright, I also want to make a save file program, so I'm going to make another thing that's save file, but let's see what all fails. Invalid operand, increment file name, invalid. So we can't just increment there, that's good to know. Instead of doing this, we'll add file name 1. Can we do that? File name's down here. We reserved a byte. That should be okay. Maybe we have to do define byte. like 10 zeros or something. I thought reserved byte worked. Or maybe we need to do times 10 reserved byte. I don't really know. Invalid operand. It does not like that. What if I want to go to the next? Move CX10. Well, I can move this into here. Wonder if I could do this. File name plus CX minus 1. The data at CX. If CX is 10, this would be file name plus 10. I don't know if reserved byte works here too. Let's just do define byte. I thought I was going to be fancy, use reserved byte. Let's just go back to defining all zeros, I guess. Whatever. I wonder if this works though. Since addressing would be 0 based, we'll add 10 minus 1 to be 9. Although when CX is 0, well, reserved word used as symbol, so I can't do that. Wow, thank you. What if I want to move it into this address, dude? Duderino. I could have sworn I could increment. Increment the address for file name. I guess I can't. Dang. Oh, this is annoying. Yeah, well, I'll keep that. DX file name. I guess we'll do that. I have to use a register. Oh well. That accomplishes the same thing by storing into that variable. We don't need to do this. Just need to do that. Reserved word used as symbol. Oh, I can't move into DX? Why not? Move the data at DX. AL. What is the reserved word here? I guess I'm not using DI yet. We can use DI. I don't know how big the size is going to be. FFFF is the max. So that's 2 bytes, so I guess it'd be word. I guess it'd be word then, if 2 bytes is the max. Sizes do not match? Would I have to move both? This is the first time I'm learning about this. What do you mean sizes don't match? What's... Crap is stupid. Move something. I have to move FS somewhere. Where do I want to move it? Since I can't move immediate values into the segment registers. AH we did too. I guess we could reset. That's fine. Let's just see if that works. That does work, okay. Jump not carry, let's just do return to caller. Alright, and then this will move above there, well, above there. Okay, hopefully that works now. Things gotta be so specific, man, dang. I should put more comments in this too. I might do that off stream though. That works, 109 bytes, dang. So there's no guarantee that'll work exactly how I wrote it anyway. Actually, if we want to do LIFO order, last in first out, we want to do file name, then segment, then offset, so we'll get, I want to do the offset first here actually. Offset and then segment and then the file name. 2 exclamations for double importance, that's how it works. And if we want to move AL to DI and then increment DI, we can just do store string byte. That does the same thing as these 2 things. I might have some screw ups here because of ES and DS not being equal somewhere. I hope not, but okay, it does load. So let's make another thing here. We're going to remove the bin file because we're just going to include it in the other thing. Let's add it to the editor, actually. Let's do that. So this is load_file.inc, and the thing is called load file. Let's edit source and editor. Okay, and this is at the bottom. Eventually I want to move this stuff to the top, but I guess I'll do that later. Add it to the to-do list. We'll include disk load file inc. And let's also put in a save file. So include, you know what I could do is just YY and then P. Yeah, that'd be easier, wouldn't it? Include disk, we'll make a save file inc. Save file to disk, or save file data to disk. It might include file name. That's not very descriptive, I know, apologies. So params, this one will be a bit more involved for parameters. I want the file name, I want the file size. Let's separate this out. In hex sectors, like we have in the file table. So the caller for save file will have to pass the file size somehow. I'm keeping that in mind. Otherwise it has no way of, how much data do I save to the disk? I don't know that. And then the memory location to save sectors from, assuming that'll be set up. Okay. Memory location to save data from. And this will be save file. Let's just do there. We'll do somewhat similar things here. A memory location, so we'll pop into BX, we'll pop into, let's just assume it's going to be FS again. And we'll pop file size, so we need to save the file size somewhere. Let's assume CX for now. And then we'll do SI, which will be file name. So how do you want to save the file? Well, saving files is very similar to reading, just first off, where we have int13.2 read disk sectors, int13.3 is write disk sectors, with the only difference being AH equal to 3. The number of sectors to write is the same, all this other stuff's the same. The only difference is it's 3, and the sector number they put change, but 3 writes and 2 reads. So we'll do something similar here, I guess. For now, copy file name to variable, which means that we could probably do some deduplication somehow. Right now, we'll do this stuff. All right, times 10 defined by 0. And these functions do clobber the registers, so I'm gonna have to, I'll probably do a push A, pop A in the caller before it calls these things. We probably have to search again, actually. We probably have to do everything that we're doing in here. Because if we're gonna save something that is already on the disk, or if we want to save a file that has the same name in the file table, we need to handle that somehow. We can make a copy of it, or overwrite the current one. Maybe ask the user if they want to overwrite or make a copy. And depending on what they choose, we make an additional file table entry with whatever data we're saving, which may or may not be the same file, the exact same data. But with a different name as a copy, or if we overwrite, it would take the same name. We're just updating, I guess, the data within there. And maybe updating the file size too. That's where it gets kind of tricky. I'm not sure how I want to handle that right now. If we're saving a file, if we're updating a file on our disk, and it takes up more data than it previously did. So if we had a file A that took up 10 sectors, and we were updating it in our editor or whatever, we save it, it now takes up 11 sectors. If that file on the disk is in between, other files, we have to do something about that. We either have to make an additional file entry, which I guess is how I set mine up. Well, if it overruns the max, but we can make an additional file entry that holds the additional data and some complex logic to handle that, or we can, I guess, move things around temporarily. I'm not sure. We kind of have to shift everything after that file forward an amount equal to the extra, sectors that were added. If our file takes up an additional 1 sector, every file that comes after it will need to be an additional sector offset from that point. So there might be a little bit weird complex logic we have to do to handle some garbage like that. So I guess I'll try to do the same stuff here. We'll compare and check, and if it's not there, we're good to go. If it is, we'll have to handle it. So let's just copy this stuff for now. Maybe I'll make an external file to hold duplicate data and it'll call it, but right now I'm not going to. That yanked it, we'll paste. So instead of returning to caller here, we're good to go. So if it did find it, we have to handle things differently from how we're doing here. I guess we could reset the disk, I don't know, but we need to handle things differently. File exists in file table and on disk. So we'll do this, go do to do, ask user to overwrite current file or copy to new file. And then this stuff will be different. I'm just going to copy this, comment this out for now, actually, not copy. Comment all this out for now. Right, current. Okay, bunch of to-dos, of course. You gotta have more to-dos than you have stuff done, or else you're not a professional programmer. That's just how it works, you know? That's how it works. So yeah, we'll ask the user to override or copy. Otherwise, we didn't find the file, we're good to go. So what if we, do we have a not? No, we're just returning a caller, right? Yeah, jump equal. If it's the end of file table, then we're good to go. So instead of return to caller, we'll call this. Well, we'll still, you know what? We'll still call return to caller, but we'll make another thing. I'll just call it new file. So instead of return to caller, we'll go to new file because the file doesn't exist. Okay, so let's just go with that case for now. If we have a new file, we want to write this file to the file table. So create new file table entry. So in our file table looks like this right now. So the issue with saving stuff to the disk is going to be, we have our current file table. If we save something new, then this file table will be updated. But in our source assembly file for the file table, it's not going to be updated with any new data. So I think I'm going to make a copy of the os.bin binary that we're going to work off of for any new data, and then the current assembly files are going to be for like a default OS build that won't have any extra data added. Although I think there's ways to add in new data into the regular os.bin file. It won't be reflected inside of these assembly files, but I think we can do some version of DD with no truncate or something to get new data that we wrote into the new os.bin and include that in the makefile build process. But just know that when we're saving new stuff to the disk and this file table is updated and changed, it's not going to be reflected inside of this assembly source. So that's just something to keep in mind. But how do we create a new file table entry? Well, assuming we did not find anything, then we are at the current end of the file table. And I will probably change this in the future to consider, I'll put in something to delete files, which will free up space on the file table and free up entries. And then we can write to maybe the first available entry that has enough space, so on and so forth. Otherwise, we want to write to the end of the file table, which is what we're going to do by default right now. So the file doesn't exist yet. We are at the end of the file table. So after we've checked all the file names, we check this, we add 16, which goes here, so on and so forth. So right now we've added 16, we're here, which is a 0. So we can write a fresh entry into the file table because we're at the end. So that's what we're doing. Create new file table entry at end of current entries. All right, so the file name is going to be file name. It's a 16-byte entry. So file name will be can we move SI to DI? Isn't that move string byte? Let me just check because I don't remember. There, move string transfers the string element by EI, so it moves the data at SI to the data at DI. So since DI points there, we can move CX10 and repeat move string byte. Or we can do cx5 string word. We'll just do byte so that you know, hey, it's 10 bytes for the file name. I guess the user right now, since I'm doing very, very bad handling of this, the spaces, they're gonna have to enter in spaces for this to work. Got the file name. We want to get the extension, so we need to figure out if they're saving a binary or a text file. I don't have that saved. Maybe I need to add a file type. Let's do that. Let's add a file type. I don't know where I'm going to save it, but let's add a file type here. File name, file type, bin or other. Memory location we got. File size, so we need file type. Where do we want to put the file type? Sort of going to be a string. Well, it could be bin, it could be txt, it could be c, it could be cpp, you know, etc. We want to save that somewhere. Let's initially save that. We'll just do di, I guess. Pop di. Let's just do that. Copy file name to variable. We move di. Let's do file type. Before we do that, right now the extension is going to be limited to 3 characters, and it's going to have to be entered in for all 3. So make a file type as well. Store stores di. We could pop into ax, right? We could do that. And then we can store like we're doing here. The 3 characters of the file type string and al, it should store into di. Well, it'll store into esdi. I don't know, we'll see if this works or not. Let's make a file type then. File name, we'll make file type times 3 defined by 0. Okay, so then we can move cx3, we can move si to be file type, and do this again, repeat move string bytes. Okay, then we have the directory entry. Well, if it's new, it'll be 0. If it exists, it'll be different. But if it's new, it'll be 0. So we can move into di. It should be okay. I might need to do esdi though. Just move 0. Can I? 0, 0. All right, then we want to move the starting sector. Which means we need to save the previous starting sector. Okay. So as we read through the file table, we probably need to save this sector so that if we add it to the end or to some free space, we'll know where we have to go from. We'll have to save or compute this plus this value so that the first available space we need is 8 plus 2 in this case, which would be 10. This would have to be 10, but we have to get that by saving or at least reading 8 and 2 and then saving it somewhere. So let's say, what do we name that? We'll say last. We could have it be next available sector number or last saved sector number, something like that. We could name this. We'll call it last saved sector. So we'll define it as 0. Okay. What we'll call it now, last saved sector. So we've reached the end. It doesn't exist. Okay. Otherwise, di is pointing to the start, so the first time this runs through, it'll be pointing to the B here in bootsect. Let's do it here. Get file size and sectors plus, well, get starting sector. Get starting sector of file and or added to file size and sectors. We need to add that to our, what do we call it? Last saved sector. We need to add it to there. So we can move into that variable, the data at that address. We can move in, di should be pointing to the start at this point. Now we could probably do add 16 here. Let's try that. Then if they put in, if the whole name doesn't match, pop di would point to the beginning and then it'll add 16, so it'll go to the next one and then recheck al against it again and then compare si again. Otherwise we'll add 16 again. I think that should be okay because we need to keep it at a constant value so that we can get an offset to get the file size bytes, right? So I think that'll work. We'll just always have di point to the beginning of the entry, or the next entries, and then compare against that. Okay, so that gives us a constant offset. So then we can do this at this point or at another point. We'll do 2dd. So let's move. Oh, I hate that I can't do stupid memory to memory. It's really annoying. I can move it into AL though, so that's okay. ESDI plus, you know, whatever our thing is here. So this will be plus, this is 0, so plus 1, 2, 3, 4, plus 14. Then we want to move that into that variable where we're holding the last saved sector location. So that's the starting sector. I don't want to do this actually, do after here. And then we can move the file size, so that's plus 15. And then we can add that to the starting sector. So last save sector AL. I think I can do this. So then that would contain, at the end of the file table, hopefully, that would contain 8 plus 2, which would be 10. And 10 would be the next area that we can save at. So when we get a new file, our file size that we're doing, our starting sector, we would need to be the last save sector, so we got to move that into EL actually. Or somewhere. We can move it into AL. I don't know if I need to put byte here, but I'm going to do it anyway. Last save sector. Alright, store string bytes. Okay, and then whatever the file size is, do we have that saved, right? Don't we have that saved? File size, yeah. Well, we saved it into CX. Let's just make, you know, all these variables for this. File size, this is going to be 1 byte for hex sectors. We'll do define byte 0. I don't know what order we need to do this. Doesn't really matter. Copy file size the variable, so let's move into file size CX. Hopefully this works, probably won't. Oh no, CX, we have to do this first because we popped into CX the file size. We have to do that first. I would have forgotten that and messed up later anyway, so that's good. So if we save the file size, that'll go in the last thing here, so byte file size and store string byte. Okay, so that should have made the new file table entry with the file name, the extension, or well, the file type, the directory entry number, which will be 0 right now for a new file, the starting sector, which will be the next available position at the end of the file table, which for this one would be 10 because we're getting starting sector of the last entry added to its file size. So 8 plus 2 would be 10. That's the next place we can put a file, so that's where we're going to make that. And then the file size, which should be passed in. So then what we need to do is write the file table. So write changed file table to disk. Since we changed the file table, it's only been changed in memory, so we have to write that changed, right now it's 1 sector, write this changed sector to the disk. So that's what we're going to do. This will have to change later if the file table takes up multiple sectors, which it probably will. But eventually we need to change this to, you know, if the file takes up more than 1 sector, we'll have to change everything else. We want to handle that automatically later on. We'll do this, assuming file table is 1 sector. So we need to set up AH3 and all that. This kind of these params up here. This, we're going to set up these params. So I'll put this in. So move AH3. Move AL, we're going to assume it's 1 right now. Track number, it's also the cylinder number, but I haven't done that yet. We're not going to worry about it. CL is the sector number. So what sector is the file table loaded to by default? Well, we have it in our file table, right? Yeah, it's loaded to sector 6. So this will be 6. We're going to write to sector 6. We're going to write one sector because that's how we have it defined here. Sector 6 is where it starts, and its file size is 1. Okay, DH is the head number, so we can just XOR that. And DL is the drive number, so really we can just XOR DX here. So when we're reading, we have this at ESDI. So ES should be okay. Yeah, ES is 0. So ES is fine, but BX we need to set. We don't set that. Well, we do. Okay, so we have to write the file table entry, and then we have to save our actual data on the disk as well. This is just writing the entry before we're saving the data. We could write the data and then save the entry, I guess. I don't know. But ESBX has to point, so we have to save BX somewhere. Let's put that down here. Call it saved BX. I don't know. That's all I'm doing right now. Which could be a word value, so we'll define word 0, because BX is 1 word in length for the full register. Let's save off BX. We'll store it. So let's move word saved BX. So we have to change BX for BIOS interrupt 13 AH3 in order to save our file table entry, but in order to save the actual data that we wanted to save to begin with, that's what we popped off into BX, so we need to save this so that we can restore it later. So that's why I'm doing this. So now that we did that, ES should still point to 0, BX needs to point to 1000 for the file table. We're writing the file table data to its own entry, which is confusing me. That's okay. Memory location. Okay, and then we should be able to do int 13. And the carry flag will be set if there's an error. Sess, well, we'll do return to caller, I guess. Otherwise, there was an error. Handle disk write error here. So we'll make another label, and it's called, I guess, write file data. I don't know. We can change it later. Write file data. Okay, so now we want to write the actual file data that we passed in. So how do we write the actual file data to that location now that we have it laid out in the file table? We do another, I guess we do another one of these, another AH3. So I don't have to set this up again, I'm just doing it right now for semantic purposes, right? And then AL is the number of sectors to write, which will be our file size. Bytes, move into AL, byte at file size. Again, I don't know if I have to put byte here. I don't think it matters because I put AL and it should know, but I'll just put it here anyway. Okay, CH is the track. Hopefully that's the same. CL is the sector number, which that is at, I guess our last saved sector. That's where I wrote it, right? Yeah, last saved sector. Let's move into CL, last saved sector. That's what we put in where the starting sector and the file table entry for this new file is where we want to write it to on the disk, because that's where it's located. So that's what we're moving in there. DH is the head number. Let's XOR DX again. Okay, and ESBX needs to be the pointer to the buffer. So ES still has not changed, hopefully, but BX will have changed. So we need to move back into BX. The word it saved BX. And this is what we passed in up here. Oh, it wasn't FS. Yeah, we need to change that. So ES points to the file table, so we need to move FS into ES. And then BX we've saved off. So that should be okay. So I need to do this stuff later. Let's move it up here. Move FS into AX, move ES. All right, ESBX should point to the memory location then. Okay, and then we should just do int 13 to write the data, because we're writing the file size number of sectors, starting at the sector that we put in the file table entry. And then we've written the data, so we should jump not carry to return to caller. Else we messed up. So handle disk write error for file here. File data. But assuming all went well, the file is written. So I guess something I could put in is like an output parameter with the status, like in Unix or whatever, you know, like in C. If your main procedure, if your program ends correctly, it returns a status code of 0. So I could have something like a status code that's returned. It says, hey, it was successful, and then print a message or do whatever for the user. Or it would be like, nope, it was not successful. Go screw yourself. No, just you look into why it errored, I guess. So error handling is a big important part of programming. I should probably consider that as well. Say we have an error variable. I don't know what I want to pop it into because I'm popping all this crap. Well, I could pop it into something, then move, and then pop the rest, of course. Could always do that. Do error code. But then I would have to get it within the caller too, which might involve popping. Let's make another thing, call it error code, find byte 0. So we'll move into error code AL. I guess we'll pop it into AL then. And move that into error code. So we can do that. That's not too bad. When we return, we want to set an error code though. So if there's a discrete error, we want to move, we'll just say a 1. We'll say a 0 is true and any non-zero number is false, or well, a 0 is success and any non-zero number for now, or maybe any positive non-zero number will be, hey, you effed up somewhere. There's an error. Signifies error occurred. So in our caller, we'll say, hey, is the error code 1? If so, well, that's bad, so we don't want to do that. And we'll push that. And then the caller can pop it off. So then we'll return. Otherwise, error code is 0 and we're good to go. I guess. Hopefully this somewhat works. It probably won't at all, of course. So save file, what's wrong? Pop AL, it does not like it, invalid. So we need to pop a byte into AL, I suppose, even though you figure the processor would know AL is only 1 byte in size. Pop byte AL. Invalid size of operand. Is it only word values? Maybe it's only word values. In which case we'll move byte. Operand sizes do not match. Yep, that's why. Okay, we'll make it a word value, you dumb thing. Whatever. It's not hard to do, it's just annoying. Oh, yeah, I changed the other one, didn't I? Yep. Move ESDI 0, operand size not specified. Yeah, I need to increment this as well. So that's good that that errored because I had to increment past that. I can move AL 0 and then store, and that would make sense, wouldn't it? That would do the same thing. Directory entry, 0 is the first, okay. There we go, 210. All right. So we have load and save files, which probably won't work, but that's okay. We have them up here anyway. Let's come up to the editor. Just get rid of this code right now. So let's try to put in saving and loading in the editor. A little bit of grit at the bottom of my coffee, that's all right. True grit. When they open the editor, I want to greet them with a message. I should also make this message a little bit better. Instead of having to put the color everywhere, let's make a text color variable and we'll define it as 17H. Instead of doing repeat move, I'm gonna make a loop. And loop back to loop. Loop to loop and pull. All right, we'll do that. I don't want to do this. I want to move string byte. Should move SI to DI. Increment both. Move SI into DI, and then what I want to do is move text color into DI, which is point to video memory. Okay, so move bytes. Can we move byte into DI? I don't think I can do this actually. Probably have to move that somewhere else, so move into AL. Can't type. Can never type. Byte text color. And then move that into DI. We can just do store string byte. Okay. Let's do that here. Because AL will not change, so we can just do this. So that should accomplish the same thing, but now that I do that, I should not need all these 17 H's anymore. So let's get rid of all these. And then, instead of doing this all separate, we can put it all as one string again. Isn't that a lot easier to look at? Let's also put a space in front to be a little bit better. So this will be 34. I don't like this being like a magic number, right, as they call it. I might make length variables, length of keybind string, and then I can move that into CX there, but we'll do this for now. I want to make another string. I should call this keybind string, maybe. I know it's a big, long word, but just to really set home, it's a string. It's the only part where it's at. Okay. New or current string, I don't know. Create new file or load current file. If I want to handle input, let's say they press a C to create a new file, or maybe they press an L to load the current file. And then I want to say when we load, I'll have to change the load file again, or well, logic for that, but at least for this editor, if the user wants to load a binary file, or like, you know, a hex, they want to load a file into the hex monitor. But if they want to load another file, we're going to load it into a separate generic text editor portion. So like a text file or a C source file or what have you. Want to load into another mode that will add into our editor for regular text editing. So that's why I'm asking, well, that's why I'm going to ask another thing. I want to pass back, I guess I want to pass back the file type from the load file function program so that we can load the appropriate editor mode, right, for that file type. That's what I'm trying to say. Okay. So create new or load current. If they want to create a new file, we're going to load the current hex monitor, although we're going to have a different thing here. Let's say S, save file to disk. Okay. Okay, let's call this keybind string length. Okay. And this is going to equal current position minus keybind string. I think this is how I'm going to do it. This would be the current offset into this file, and this would be the label. So I think it would be, since this is after, this would be equivalent to the end of this string. The keybind string is defined as this whole thing, so that should be the end of the string minus the start of the string, I'm hoping. I can do this later, actually. Let me do this first. I'll just count this out. That's 58, according to my very basic numbering rules. 58. Okay, create new or load current. I want to make choose file type string. Say text or other. Let's do binary. We'll say if the user chooses to create a new file, what kind of file do we want to make? If they want to make a new hex file, new binary file, we want to bring them to the hex monitor. If they want to make a different file, we'll bring them to the text editor, regular text editor mode. So say binary / hex file or other file type, text, etc. Well, before we put in the code to create a new file and save or load file. Let's first see if the stuff even works, which it probably won't, so we'll see. Check file name is already defined. Oh, because I have it in both. Yeah, that's why. Okay, which one am I loading first? Or well, we'll change them both. Yeah, check file name I've defined in both. So we'll do check file name loading. And this one we'll do check file name saving. And we also did compare. This is fun. Compare file names. I know these are long label names. We might change them later, but we might not. I don't know. I think it makes more sense than really short label names. Come on, compare. Just these two. There's probably other same ones. Is there other same label names? Maybe. You know what I could have done is did what I did for the dot loop, named them dot check file name. Then it probably would have been okay. But I didn't, so we're going with this. Restart check as well. Where are you? And found file. Is there any other things? Return to caller, we named the same thing, didn't we? And these file name variables. I guess we'll change it, whatever. Weird. Let's need these. All we have here is file name actually, so for now. Undefined symbol, of course. So we'll rename that loading and rename that loading. This is saving. Saving. This is a terrible way of doing this, but it's just what I'm doing right now to get this to a symbol. Undefined symbol, return to caller. Yep, return to caller saving. So where am I calling? Hey, there we go. I added another 200 and 100, so I probably added another 300 something bytes to the editor. But what do I have the... I want to make sure it works. I have this as 2. Let's make it 3 sectors. I added another 300 something bytes, which is less than 512, but let's just do it to be safe. Let's add another 512, so that'd be 1536. Okay, so the editor takes up 3 sectors now, which means I have to change the file table. See, I won't have to do this in the future, hopefully, once I put in logic for the save and load files. It's a little worse now because I'm putting it in late, but that's okay. I won't have to change it my program logic for the functions. I just have to change this here. This takes up 3. So the first time we save a new file, it should go to 11 instead of 10. Let me see, actually. Let me see something. If we go to the build directory, if we run QEMU system i386 FDA, if we run it in the other, if we do this, it does work. Okay, so I want to put that, I want to put a make run in the make file that runs that. So let's do that right quick. Got to do make file changes, of course. I don't think I ever explained the phony. The phony is just if you have the dot phony in your whatever your targets here, whatever they're called, requisites. If you have a file in the directory that the make file is running from, and its name is clean, then it may or may not run changes on that file named clean. So this is just saying, if we have a file named clean, sort of ignore it or always run changes, which means it'll always run this clean down here. But I'm not really anticipating having a file named clean, so I'll just get rid of it. But let's make a run command again. QEMU system i386, 87, 86, 85, anyway, eventually in the bin directory for the os.bin. Okay. Because now if we're in this directory, we can do make, and we can do make run, and hey, it runs. So let's see if that string was printed in the editor. It was. Okay, well, it goes beyond it a little bit, because SI data has been changed at this point. So let's go and fix that right quick. So SI is running into here because this is defined byte, makes this appear right after this in memory. I guess 58 is too much. Let's try 56. And there we go. S, save file to disk. While we're at it, since that run code return is capital, let's make that S capital. Okay, so I think I'm going to stop here. I'm going to splice in other stuff onto this video, probably to make it really long, maybe. I guess this is just the setup and nothing really happened, so I don't know if I want to release a video like that. But definitely in the next part, if I do or don't splice it in here, we'll put in saving to disk first, and then we'll go and put in loading to load what we saved. So we'll put in saving to disk using the parameters that we put in for a save file function, and hopefully it works. I'll put in stuff for these messages here, maybe to start off with. Create new file, binary hex file, put in a C then a B, then it'll load the current hex monitor. Or if they do load file and it's a binary, then it'll go to the hex monitor with the data loaded. So I'll put that in the next part. We'll try to get some basic test hexadecimal bytes saved into a new file on the disk, and then load it and run it and see what happens. And then if we save it as a file on the disk, then in our main shell in the kernel, we can then run that file because it'll be saved to the file table. And we can, you know, it'll be pretty exciting, I think. Also, I might want to change this. When we put in the C3 for a return, the return opcode to the processor means pop an address off the stack and then jump to it. So instead of jump, I think we need to do a call, because that will implicitly push an address onto the stack, and then the return from the C3 should jump back to that address and then go back here. Do I have the test? Yeah, let me see what's in. Test assembly test up in. Well, let's cat that out. Print out a T. All I'm doing. So let's do FASM test.assembly, which should work. I don't have that in the current one. Okay. So XXD. So B40E, D4 CD10. Editor, so B40E, B40E, B054, CD10. I should print a T, but I guess it printed a T and then returned, so we didn't see it. So let's try B40E, B054, CD10, F4 to halt. I saw a T there for a second, but it went immediately on. We might have to clear interrupts and then halt. We might have to do that, so let's do that. And halt. Okay, FASM test. All right, CD10, FAF4, FAF4, okay. All right, FAF4, there we go. So we halted, just so we know that it works. If we don't clear the interrupts, then it goes on past the halt. Because I guess there's still data in the stream somewhere and it returns. But anyway, that's how that's there. So now we've halted, we can't do anything. But anyway, just wanted to show the editor still works. Okay, so I'll do saving and loading functions I want to put into the editor, and we'll do, I'm sure it won't work and we'll have to debug for a while, but that's okay. I'll put those into the editor, get some basic thing working, and yeah, I'll either splice that into this video, which will make it really long, but maybe after editing it won't be, we'll see. Or it'll be the next part, but anyway, I'll see you then. All right, going to continue with the OS dev here. I'm going to hopefully better structure function calls or file calls, the include files where I'm doing stuff like the load and save file. I want to try to set up the stack a little bit better than I was doing and make it more towards the actual sort of C calling convention here. So I found a nice little chapter about a book online. But basically, you know, goes in and explains the 32 or 64-bit C calling convention in more detail. It's the callee for the caller. When you're calling something, you know, push your stuff on the stack, call the function, and then you can add to the stack pointer afterwards to kind of deallocate the values that you pushed on the stack. This is a 32-bit example, and I'm in 16-bit real mode, but it still works pretty much the same way. It's just more or less space is taken up when I'm going to do it. But, you know, he's pushing three, you know, variables, pushing a variable data value at this address, pushing immediate value, and pushing a register. These are all 4 bytes long because they're all 32-bit. And that's why he's adding 12. Add 12 bytes to sort it. Since the stack grows down, you can add, you know, the value of these 3 to kind of deallocate them from the stack after you're done. It's pretty simple for the caller. The callee, or your function that gets called, you can push the base pointer, which I think is set up by default when you set up the stack initially and the stack pointer initially. I think the base pointer is known and it's set up so you don't have to mess with it. But when you're calling a function, you can save the caller's base pointer. You can move the stack pointer to that to reset it for this local function. If you want to do a local variable on the stack, you can subtract more from the stack pointer at that point. You're messing with any registers, you can save them here. Where I would do push for individual, you can just do like a push A here and then a pop A at the end. But you know, you mess with the stuff in your subroutine, you can use the stack. If you pushed, you know, like if you push 3 4-byte values to access those in 32-bit, you can use the base pointer here. Since you set it to the stack pointer, you can offset from the base pointer for everything, which makes it a little bit easier to reason about kind of explicitly instead of trying to remember pushing and popping. You can just use offsets from the base pointer here. So since the first value was pushed last onto the stack, you can access that from base pointer +8, and this is +8 because the base pointer itself, for this 32-bit example, the base pointer itself will be 4 bytes, and then when you call, you use the call mnemonic and you call an address and jump to it, that implicitly pushes the address onto the stack. In 32-bit mode, the address would be 4 bytes. So the base pointer is 4 bytes. The address that was pushed onto the stack when you called this function was 4 bytes. So that is why the first variable you push will be at byte 8. And there's also a nice diagram here. Base pointer is 4 bytes, the return address when you call, and then you have your parm at +8 because this is 4 and this is 4. So this is at 8 and then 12, 16 respectively. And then if you make a local variable and you subtract the base pointer in the function, then you can access that and then whatever other registers you push. So after you push everything, the stack pointer will be here, approximately at this area. So, you know, subroutine body, you can mess with the local variable on the stack if you want. When you want to end and go back to the caller, you can pop your registers that you pushed to begin with, or if you did a push A, this would be a pop A for everything. You can reset the stack pointer to the original base pointer amount, so it's kind of the opposite of what you're doing up here, and then pop the base pointer back for the caller. So basically you want the caller's stack to be the same before and after the function. So that's all this is taken care of in a more formal way and kind of an easier to reason about, more explicit way by using offsets from the base pointer. That's kind of what I'm going to be going towards. Hopefully that kind of made sense. Again, I'll try to put a link to this in the description because this explains it a lot better than I ever could, and it's pretty short, like 7-page PDF. But that's what I want to change for the load and save files. So I'm going to try to do that here. So big O, everyone loves their big O notation. We'll do load file and we'll get the other one, save file. I know there's a lot of redundancy in these, and I kind of want to abstract that into a singular thing, but I'm not, unfortunately. What we can do is save the base pointer, right? So first we want to push the base pointer, so let's do that. Then we want to move into the base pointer, the stack pointer at this point. All right, I don't know if I'm going to use local variables or not, so we don't really have to worry about that, but I am going to mess with these. Instead of BX, FS, and SI, I guess we could push those, or we can do push A to put them on there. That should be fine. So let's see where we return down here. Pop A. And then we want to move base pointer back to the stack pointer, because that's what we did up here. Stack to base, base to stack. Then pop the stack pointer. This is more overhead, but it's kind of more, I guess, more commonly found in actual professional assembly code. So this is like the C calling convention. Okay, and then we can return. So I think that's what it was. Pop the registers, move the base pointer back to the stack, pop the stack. So in mine, we're in 16-bit mode, which means one word values, I believe, for the stack and base pointers as well. So they would both be 16-bit, or 2 bytes. When we push all the registers, that's a lot, but the base pointer is the original stack pointer, so we can use a base pointer offset here. So we popped into BX. This will be the first parm, which we kind of want to be the memory address for the offset, which would be 2 bytes. So since the base pointer is 16-bit, it is 2 bytes, and if we call load file, then the address on the stack will be 2 bytes. So that would be 4 bytes overall, so we should have to do +4 to move into BX here. So we should be able to do BP +4. And then we can do the same for these. Instead of pop, it'll be move, and it'll be BP +6. Again, assuming it's a one-word address, we'll do BP +8. If we're loading to AL and storing AL to DI, could we not just do move? Would move string byte not work here? Why are we not doing move string byte? Because this increments SI, this increments DI. Can I not just do that? Let's just try, maybe I changed it for a reason and I forgot, but let's just do that for now. Move string byte. That should be the equivalent of SI to DI and increment both. So let's just try that. Reset, okay. These should all be okay. And then in the caller, we would add to the stack pointer to deallocate. I think this, well, that should be all right. These are usually called the prologue and epilogue, I suppose, or, well, maybe they just call that in academia, but I'll use it the same thing here. Function prologue, at least for now. I'll state these things explicitly because I'm learning. All right, and I want to do the same thing over here. Do that, get parms off stack, reverse order. Let's put the epilogue down here. Function epilogue. And P, there we go. Alright, so get parms off the stack in reverse order. Instead of AX pop, we'll move into AX if we want to do the error code. What we could do is just put the code in AX and have it implicitly return, I guess. Instead of having AX be an extra value on the stack we have to push, we could just return AX. I think is also in the standard C calling convention. The return values are in AX or CX or DX or whatever. Let's just say AX will be the return code. Maybe we'll push on the stack anyway. Which means we're not going to mess with that. I'm trying to think if that's what I really want to do. If we had an error occur, I guess we can push the error code onto the stack. Yeah, so it'll be pushed onto the stack anyway. I don't know. We can move it into... We could just check AX at the end. Although the pop A would not work at that point. We'll just go back to it. I don't want to think about it. We'll just go... we'll just go back and do that. Alright, so we'll say the error code's the first one or the last one. So let's do... BP plus, it was 4 for the first. Alright. BX will be BP plus 6 for the second parm. Need a lowercase a. There we go. BP plus 8 for the third parm. This way we don't have to worry about pushing and popping everything here. Just using offsets is a little easier, I think. Although we pushed a and then we popped a, so when we return we'll have the original value in AX. So I don't know if I want to do that. I guess we will do the local variable for that. If we want to do an error code, we can do, before we push a, let's subtract 4. For our case, we'll subtract 2. Let's do that. Local, call it stack variable. This I'm gonna make the error code, I suppose. That means we will get rid of it. I know I keep flip-flopping on this, sorry. It's just hard to know what I'm gonna do right when I'm doing it. Stuff is likely to change all the time, you know. Alright, but these will be less than 6, 8, 10, 12. Let's just do that. We'll push the ones we're actually using for this because it'll make more sense. This loop I can change as well, like I did over on the save file. This should just be a repeat. Repeat move string byte. That should be all we need to do. That'll replace load and store. So pop in reverse order, right? So we'd pop SI, because we pushed it last. Pop CX. Pop FS. Pop BX. Instead of AX, let's see if we can do DX. I want to use AX after we pop them all. Well, before we pop them all, let's move. If we put our error code into the stack, instead of doing push here, we'll move into BP -2, right? The data at error code, which would be 1. Move word. So that's our error code variable on the stack. And if nothing's there, we don't worry about it. It could be a 0, but we'll move whatever's there into AX, I guess. Because it needs to be a word. Put error/return code. Okay. Restore change registers. Okay, then we should be good to go. So we need to move file type from DX to AX. So move into AX DX first, and then we can do that. We can check that value. We can check AX when we get back. Okay. So AX is not affected by the other things we're doing. All right. Let's look at editor then, where we're using these things. So now let's figure out wherever we want to call. So where do we want to call? Let's do this first. Where do we want to call load or save file? I guess when we load a file, right? Create new or load current. When they press S in the editor, that's where we want to save, because I did S equals save. They're saving instead of running, so where are we taking in user input? Let's make a save. We'll just do save program, I guess, or save input. I don't know. Save program is fine. This will be capital S. So if they didn't go to run it, or they didn't go back to the kernel, well, end input is actually run, isn't it? Let's do run input instead. That's the only time I did it. Okay, that makes more sense. Run input, you're running what you typed in. So if they didn't run and they don't want to end and go back, we'll check. Compare AL to save program. Does user want to save? All right, does user want to save? If they do, we'll go to save program. Else, if they don't want to save, then, you know, we'll do what we normally do. And editor, let's put it down here, I guess. So how do we signify the user's made a new file? And then if they want to save, if it's a new or an existing file. If they want to save an existing file, I guess we'd have to load the file name from the program for the file table and everything. I guess we'd do that in the load current file. But right now it's new. By default, it's a new file. Placeholder. Let's go back to get next hex character. Get next hex character. So when they first come in, the screen is cleared. They write the string, which we only want to do this if they're going into the hex monitor. Let's do it right after they clear the screen, I guess. I do want to change the other, like print string and everything. I want to change these to stack better with the calling conventions, but I'll probably do that later. I'll print this, it'll be at the top, but that's fine. We'll call print string, we'll take in input, I guess. Or well, we can do AH. I don't know if that takes up one less byte or not. We'll get a keystroke, and we want them to press C or D. Let me just, I guess we'll just put them up here along with the other constants, right? So create new equals C. Load current will be equal L. Binary file will have equal, oh, we call it bin file. Bin file will be a B. What else? Other file will equal O. Okay. So what did the user press? Did they press create new? This will be the default right now, but we'll just say that. Did they press create new? If they did create new, let's go to create new file. Else, load cur. Well, I did load current file. I mean like existing. Current doesn't make sense, does it? Let's change that. That doesn't make as much sense. Load an existing file. Let's say load file, well, load existing file. Put this right here for now. Create new file label. We'll move the other string, which is choose file type. Call print string. We want to check again. So we'll say, which file type do you want, binary hex or other? So we'll compare AL to bin file, which will be a capital B. If they did, we'll go to the current thing, which is hex monitor. So do I have anything called hex monitor in this? No. Or hex editor, or whatever we want to call it. Could be editor, I guess. If we load the file, we'll load the hex bytes, so then we'll kind of, I guess this is kind of an editor, we'll call it hex editor. Else we'll compare AL to other file. We'll do a generic text editor instead of the hex editor. So it's really nice because they sound alike, so it's going to confuse me later when I'm talking. That's even better. That's okay. Even though we don't have these other labels, we'll probably get an error on assembling that'll say these labels don't exist. But so assuming they do a new binary file, we'll go to the current hex editor. All right, and then if they go through the current hex editor and they want to save, we'll go to the save program down here. And at the end of this, we want to go back anyway, so I'll keep that jump there. So when they save the program, we'll probably want the user to input a file name, right? Because we're going to be using that file name. Let's make another string, yet another string. I guess we'll call, well, we need something to hold the file name to. We need the address of it, don't we? But then if we do this, these ones have file name as well, and they're included. This I have file name, well, file name saving. File name string, so I guess it'll say file name with a space. And then they can type. Oh, I'm not moving these. These need to be null terminated as well, or that's going to error. For call print string, these need to be null terminated. For ones that I'm just writing to video memory, they don't need to because I'm passing the length. But these ones I'm not, so. Enter file name. If we print this over what the user's typing, well, if they go to press S, this will just pop up on the screen. We may want to, we should have our hex code saved in the hex code area, so we shouldn't have to worry about that. But we want this to pop up. Let's just clear this screen and then do that. Call clear screen text mode. Okay, and then that'll move the cursor up, so then we'll move SI, the file name string. We'll print that out, so the user will enter stuff in here. Up to 10. I guess they'll have to enter in spaces right now. Or if they don't enter in spaces, we can pad out with spaces. I'll call it input. Inputs file name loop. So it needs to be 10 long, right? So we'll move 10 into CX. So we want to XOR just AH really for int16 because we want to get an input from the user, get keystrokes from the user. I don't know what I just did. That's all right. And then we kind of want to store that somewhere. We want to store it in an address because we need to move it. So we don't want to name it file name saving or file name loading because that's what they're named in these other files. But we need somewhere to save the file name. I don't like naming. I'm putting too many variables and I don't like it. That's all right. We'll do it here. Times 10 db0. Let's move this to di. And then we can store al in di with store string byte. Okay, and then decrement. I guess we'll just do it till they enter in 10, and then we'll say, okay, say, well, this won't show the name though. We kind of want to show what they did as well. So let's store it, and then let's print out the character. Or 0EH. What all do we need to push to call? We need the file name first. Okay. So I'll just put down here, call, save file, function. We'll push editor, file name, push word. First input parameter. Okay, then we need the file type. So the file type for this will be bin. Probably should use an address for that, shouldn't we? So editor file name, we'll make editor file type. I hate doing all these. It's pretty bad. Times 3 db0. Editor file type. This will be second. Okay, we need to fill file type though, so when they do save, I guess I'll do that. Can move a B. Well, we can probably move. Can we move a double word? We'll just do byte. But then we can't increment, so never mind. Oh yeah, we can. +1, we'll do I. I did not remember if the bin or txt or whatnot was a lowercase. It is lowercase, okay. So bi we'll do +2 will be n. Okay, push file type. Alright, what's the third parm? Name file type, file size. So we need the size of the file in sectors, so I didn't think of doing that yet. So when the user is typing in stuff, we're going to have to save, or at least keep track of the file size. Let's do that. Editor file size. Well, it'll be how many sectors we have in the file table. So we can do 0 to 255 for one entry. That's 1 byte. We just need to do a byte. So whenever they type in a character, I'll want that to be 1 byte going to the final file. And then we'll have to do, I guess, that number modulo 512 to get the number of sectors. Right now I only have 255 for hex code. I can make this a different number. We could write to some location in memory like hex 10,000 or something, or we could have as much room, a lot of room, like 400 kilobytes if we wanted. So I might change to do that. Right now this just can be 1 sector, but if we keep track of the file size, so when we put the hex byte, we want to increase the thing, because that's when we actually do it, when we put the hex byte in. Rotate left or move store. So when we store it to the memory area, we'll want to, okay, increment byte at editor file size byte counter. Okay, we'll do that. It'll start at 0. Of course, we probably want to reset that whenever we enter this program, though. Let's do that up here. That doesn't have to be up here, but if they make a new file, yeah, if they make a new file, then we'll do it here. So we'll move bytes. It'll be editor file size. Let's move a 0. Reset file size byte counter, because at this point it's a new file. Well, not necessarily. Never mind. If they do create new file, it will be a new file. So we'll do it. This is a new file anyway, so we'll do it here. Yeah, that's fine. If we're going to load a file later, we don't want to reset the counter. We want to get the actual size, so we'll just put that there. Whenever they actually put the hex byte in, we'll increment it. Okay, so we'll have the file size. File size in hex sectors is probably just going to be 1. What am I doing with the file size here anyway? CX? Okay, well we'll just do a 1 right now for file size. Push word 1. Third parm, file size, and hex sectors. So I guess we should change the hex code. Instead of using this hex, well, we can still kind of write to this. It'll be different though. This is kind of stuff that would be easier in 32-bit mode, because you could use, you know, large memory addresses like 5 digits, like 10,000. You could just move 10,000 to a register or whatever. So I'm going to assume, let's assume I want to write to memory location 10,000 or segment offset 1000. So I guess we'll try to do that. So currently where I'm running the code, DI points to there. So, and then we're storing it into DI later when we do put hex byte. Store string byte will store to DI. Okay, so instead of doing this, where we restore, we go into the hex editor. So let's do ES. So let's move what ES would point to. We can just do 100. Then ES would point to 1000. 1000 is the file table, so we do have to do 1000, right? Move ES AX. So if I do this, move 1000 to ES and then XOR DI to 0. So ESDI should be 1000, right? Offset 0, which should equal 10,000 in hex. So hex code, we're going to assume our location is 10,000 or 1000 offset 0. When we store string byte, it's going to store to location 10,000. So put hex byte into hex code memory area. So this will be at 10,000. Increment DI. Okay, that'll still work. It's just instead of actually doing that, we're going to be writing to 10,000. So where's hex code here? That's the only place it is. So we will call ESDI. Well, we should XOR DI before we do this. Since we moved the byte here, that's still fine. So let's do XOR DI. And then instead of calling hex code, we should be able to call ESDI. We should be able to do this for a far jump, I'm hoping. So the fourth parm will be the segment, right? So we should be able to push ES. And then DI was the other one. DI will be 0. In this case, so we probably can just do push word 0. Hopefully. Offset memory address for file. So that should be it here. After we push everything, we want to call. So we'll call save file. And then to reset the stack after, we want to add however much we pushed, which be 1, 2, 3 would be 5 words, so it'll be 10. Okay, and we can check, because our error code will be in AX, so I guess we'll compare AX to something. So AX will be 1 if there's an error, or well, not 0. So let's compare AX to 0, and jump not equal, or we'll do save file error. So we'll make a thing here, save file error. I don't know what I'm going to do here. We'll just have it do the normal thing. We can like print a message and go back though. Could do that. We'll make another thing. Let's make another thing. We'll make another string, why not? So this will be save file error message. I could call it message and not string. Whatever. It doesn't matter. Save file error occurred. So we'll do that. We'll move SI. What if it didn't? What if an error did not occur? Save file success. Otherwise, we'll jump. Save file success. Okay. Save file error message. We'll call print string. After we save the file, we could either keep what they typed in on screen or clear it and then restore it after. I could print it at the bottom of the screen, like where my current message is. I guess I could make that like a message area. Where I'm typing like the keybind string down here, I could make this have the error message. I guess I could do that. And then I wouldn't overwrite what the user's doing. So 24 is the length of that string. Let's do that. Length of string 24. Alright. So we're not worried about ES at this point, so we can do this thing again, move ES vid memory, well, AX. Word DI. So save file error message, CX, the length of that is 24. I'll have a different way of getting lengths later on, I think, hopefully. I don't like typing in, hard coding the lengths here because that's very error prone. We'll do this again, move string bytes, store string byte. Alright, so that'll write the message at the bottom of the screen. And then just for good measure, it doesn't matter what they put in, but just for good measure, I'll put in a keystroke so that they can see. You'll look at the message at the bottom, you'll press anything to continue, and then we'll just go back, I guess. But it'll say it failed. And then when we go back to get an hex character, what we need to do is we need to write the keybind string back, don't we? And so we're doing that multiple times, so we can make a little thing down here, not unlike a subroutine. Do write message, write bottom screen message. I don't know. This is very long, but let's make a little thing right here that does this stuff. I don't need to clear the direction flag, but we'll do this. But I need to pass the length. Oh, that's annoying. I need to pass the length. And we'll return. So let's pass these two things, and then we'll call write bottom screen message. And we don't have to do that stuff. And then it'll return and go back. So then in the error, we just have to do these two things. Call write bottom screen message. And then when it returns, we'll take a keystroke. Okay. I'll just do that. Move SI and CX and then call. Let's put here, which is message to write is in SI, length of message in CX. Okay, little kind of subroutine type deal there, that's alright. We might see where this goes and then try to debug everything that broke, and then that can be the end of this episode. It's not loading a file though. Let's maybe try and get something to save I guess, and then print the file table and see if it actually did save for like a test. Call ESDI invalid size of operand. You can call a label, but you can't call ESDI. I should be able to do a far call though. I think I can do a far call and a far return. C3 is a near return. A far return is CB. Okay, so let's put a CB in there. Yes, let's do B, far return. So instead of doing ESDI, we'll call 1000, call 1000x, H, rather. Input file name loop. Oh, we didn't do anything with that. Now I'm doing, oh, dot. Illegal instruction. Where's this at? 118, really? It doesn't like that? Oh, I need a label. Duh. Load existing file is an undefined symbol. That's fair. I don't have, you know, like live. This isn't a good IDE or anything that has red squiggles immediately when you mess up, so. Yeah, load existing file we don't have. Load existing file right now, we're just gonna have go to the hex editor, so. Let's do this. To do. Fill this out. What else did I not? I probably didn't do another thing either. Text editor, that doesn't exist. So we'll have this do the same thing. Oh no, it assembled. That's not good. That's never a good sign. Alright, let's see what breaks immediately. So let's see, first of all, this is all we got here. So hopefully a new file is written at sector 11 and a size will be 1. And it'll be after editor. That's what I'm hoping for. We're not able to load it, so create new or existing. That shows up, that's good. Let's say a new file, capital C. We should probably clear the screen before asking this. Let's do that. And then we call choose file type. Let's clear the screen first. Call clear screen text mode. Alright, so new file, binary, hex, or other type. Let's do a B for binary. So we should clear the screen one more time before we can enter it in. Okay. Clear the screen one more time. Let's do that here. It's alright. New file. We want to do binary. Okay, we have our regular stuff here. So let's put in something to write a T to the screen, which I don't remember. So this will clear the screen and halt, I guess, is what that does, right? Yeah, clears interrupts and then it halts. So I can do that. B40E, B54, CD10, FAF4. So I was going to save that on my other monitor, but I can just keep it up here. New binary. That should all be saved to the file. So let's do an S. The file name will be TEST. I like how it's writing in the screen. That's not a good sign. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So it should have saved it. So we need to clear the screen after we save it. There wasn't an error, I guess, or it would write errors. We can type stuff in again. So let's go back to this. Okay, I do not see it in here. We didn't load the file table again, did we? Or did we? So we're storing to the variable, which that's an ESDI. And ES is still pointing to video memory. Ah, yeah, that's not good. We moved DI editor file name, but ES is still pointing to video memory. So ES here needs to be pointing to wherever we loaded this thing to. 800, yeah, extra segment 800. Where are we writing? Input file name loop here. There we go. Restore extra segment, then we'll do that. This is the file table location in memory. I'm not loading it again though. I probably want to load it from the disk again when I do this, right? Because this is just setting it to the memory location. So if I write something new to the file table, it may or may not be updated on the disk, but the memory location where the file table is at currently does not reflect the data that the disk has at this point, right? The disk has changed, but the memory's not changed to reflect that. That's probably why it wasn't there. So let's go ahead and, well, we need to load from the disk then. And we could try calling our load file function, or I'm just going to load it again. Even though we load it in the boot sector, we're going to load it again here. So let's put it here. So let's load file table sector from disk to memory to get any updates, which is int13ah2. And 13ah2, let's do over here, let's do, I can't remember anything, read the file table, move bx 100, that's where we want to load it, which is fine. Move bx, xor, bx, move cx, target sector to read, okay. Let's just put that down here. Or I can move AX. Yeah, this is kind of pointless because I'm trying to do a load file function so that I can use in place of doing all this. But I haven't tested the load file function, so I'm not sure if it works. That's why I'm doing this manually right now, to test if the save file works, and then I can work on the load file after the save file kind of works okay. All right, then we int13 to read the disk sectors. Retry load. I don't even know if I need to do this, but I'm doing it anyway. Retry loading just in case. ES should still be set to 1000 at this point from above. BX should be as well. So that should be all we need to do. Oh, we're good there. So let's see if we messed up. Nope, that still works. That's good. So we're gonna have to retype in our stuff because we're, rebuilding the whole OS. So any changes that we would have made are overwritten from the, the source files that we're using to build. So file table, even if we update file table on disk at the current moment, when we run make, we're using the file table.asm file to make the file table binary, and that's gonna, reset it every time to whatever the assembly file looks like. So that's why these changes aren't gonna be saved every time we build the OS right now. Which I'll change that later though. And we'll do S, we wanna name this TEST 1, 2, 3, 4, 5, 6. That should have saved it. I do want to clear the screen after they do this and maybe put in a thing that says press enter to save or something. That might be good, but this is still saving, so we're good there. Looks like we need to reset video memory again after we do this as well. But let's go back to the kernel. Let's try directory again. Okay, so we see we got some output, which is good. We have test. We did not get the extension correctly. That's okay. Oh, it looks like it did write an entry though. Otherwise, this wouldn't have been updated. So the extension does not work. Entry's fine. The start sector should be 11. That is not correct. And the size is 1, which is correct. So the starting sector and the extension are not correct. So let me save this. But we did get a little bit of output, which is nice. Our save file. Hopefully it's just an issue in here somewhere. File type did not really. So, and that's because we're moving file type to DI. But we are moving DX to AX, and repeat store will only store the first thing that was there. And I pushed word editor file type, so that should have been the address. And when I'm getting that off the stack here into DX, DX should hold the address of editor file type. Move DX to AX should be the address. So storing once will not work. We're going to have to store and then increment. 3 times. Store, increment once, and then twice. Or we can just move it in there. Store data, then increment. Then we want to store and then increment. And we want to store and then increment. I don't know, we'll just do this right now. So other than that, the starting sector looked to have messed up. So what is the starting? That'd be our last save sector here. The file name was correct. Search file table for file name. We did not find it. So this was not right. DI is 1000. That should be the location, although we can do 100 offset 0. That's fine too. But this should have worked, I thought. Let's make this a little bit differently. Let's make AX equal to the address of this sector. We can still move that to AL. We could set it to SI and load it. What if we did that? What if we made this DS and this was SI? Although I'm probably messing things up. Yeah, because this is SI over here. Let's change it. Since we were doing 100 and 0, I don't know if that would make a big difference or not. But let's change it to do that. We'll use ES again for that, and we'll XOR DI. And ESDI plus 14. I was assuming that was going to work. Maybe that doesn't work, though. What we could do is add DI 14. This is going to be really stupid, but that's okay. That should move the byte at DI to here. Increment DI, move this again, except this will be file size. Well, I want to add that to AL for the file size. Oh, that's okay. Let's do this. Yeah, move that and then add, and then we'll move AL to this. So we'll add it up in AL, which is the accumulator anyway, and then we should put that in the location here. So we should need to just subtract 15 to reset DI at this point. If it's the end of the file table, it doesn't exist. Oh, maybe this is what went wrong. Maybe I don't need to do this at all. If we're adding 16 and we're moving this in to begin with, and we're not at the end, if we're at the end, it's going to be 0. We're already doing this even if we were at the end of the file table, which would just be zeros. That's why it could be 0. What we need to do is check this first. But we won't know we're at the end until we get these things. Okay. Can I do this? Can I compare the memory at DI to 0? Guess we could do that instead of checking the name. If it doesn't have a starting sector, then it's new. Otherwise, we want to move it and take the starting sector. Then I wouldn't need to do this. If it doesn't exist, we don't want to take the value of the starting sector, which would be 0. If it does exist, we do. So maybe that'll be different, maybe it won't. Those were the only two things that were messed up, were the file extension, file type, and the starting sector. Hopefully that doesn't mess anything else up. Well, I'm pushing DI up here. Am I popping? Oh, I am popping DI, so let's move. A new file will probably have to subtract 14 from DI if it's 0. Yeah, I'll just subtract 14. If it's at the 14th byte, we'll just subtract for the new file down here. That is the only point where we're doing new file. It's right there. Did I mess anything else up? I probably did. But I don't know what it is at the moment, so we'll find out. No, operand size not specified. Compare DI 0. Compare the data at DI, well, I guess it'd be a byte, wouldn't it? Compare the byte at DI. It's just 1 byte. 1, 2, 3, 4, 5, 6 spaces. All right, let's return. Oh, print rank directory. Oh, it's broken. It's broken. Look at that. Does it work by default? It doesn't. Ah, yes, ESBX. This is not true anymore because ES was changed to 100. We'll just do that. ES was changed to 100 up there. Now we're changing this. Was that the whole issue? That would be awesome if that was the issue, because that would be easy. That would be nice. E40. I guess I could put in whatever here, it doesn't matter. I'm just trying to put this in a lot to remember what it is, so that I can use it as an easy test later on. Oh, moment of truth. Well, the start set, no, wait, no, that's not right. We put test in the middle. That's interesting. And it put a K for the start sector. Let's just XOR them. Let's change it back one more again. ES will be 0, DI, whatever, we'll make 1,000. That's fine. So I think that actually did work before. Add 14. We'll just do the offsets again, because it actually put it at the end to begin with, and I'm messing things up when it worked to begin with, so let's just change that. Change it back, ESDI, I'm assuming this did work, ESDI plus 14. Move that data to AL, so then we'll move bytes. Well, we can still compare, we'll just do this. Oh, if it's not, we'll try adding to AL. I'll just do that. Starting sector, we'll add file size and sectors to AL. If that's empty, we'll get a new file, else we'll do this. Otherwise, we don't need to subtract, we'll compare. We'll add, go to the next one. Okay, but this needs to be moved in there if there is a new file. If there is a new file, we need to do this. We need to do this and do this. So put it down here. Get rid of that. We don't need that. We got last save sector saved if it's a new file. Okay, if it's not a new file, we're not even doing anything for current files anyway. When we do current files, we'll worry about it later, and we'll update the file size and stuff accordingly. But right now, we're not. So the new files, this should have the correct last save sector, hopefully at the end of the file table. So this is probably gonna not do what I want again, but we'll see. What else is broken? So the extension is garbage. Well, I want to figure out the extension issue. So I'm gonna do that, and I'm gonna come back when I figure that out. I'll get back to this. I'll find why the extension's not working, and then try to fix up the start sector not saving correctly, and then we'll go from there. So yeah. Okay, I'm back for a couple minutes just to show, I got the extension working here right now, so I'm going to show that. I did not get the start sector working yet, I'll work on that after this, but let me show you how we got that extension working. So, save program. Okay, so I changed where I'm restoring the extra segment up here instead of down here. The file type, I'm just moving the editor file type address to DI, and then I'm moving the letters into AL and then storing. I probably could move them directly into editor file type, but I'm just doing this right now. We'll change to do whatever equivalent that works better later if we want. But this seems to save it all right. Okay, this should be the same right here. I just moved this restore up here, and I'm doing this to save bin if it's a binary. And when I'm calling, I'm not sure if I have to do this, but I put this here more explicitly just to tell. These are 2-byte one-word values, so a 1 for the file size. 1000 is the segment memory address. I don't think ES was set correctly when I did this, so we're just saying, hey, it's 1000, and then 0 is the offset. So I think that might have fixed a little bug as well. And I think that's the only thing I changed in the editor. In the save file, I changed stuff a bit. When we're copying the file name, I'm doing what I did for file, well, when we're doing the file type, I moved it after the file name. I'm basically doing the same thing except 3, moving 3 into CX. Since we're copying file type parameter into DX, I'm doing that, moving that into SI. And then our file type variable in our save file, I'm moving to DI. And then repeat move string byte from SI to DI, so it should take the 3 bytes in the file type pretty much all I did, and that fixed the extension. But just to show that this works, you know, I'll do this again, make and make run. Well, let's check first. Directory, nothing there. We'll do 3, 4, CB, we'll do whatever. We'll just do capital S, test, 1, 2, 3, 4, 5, 6. Whatever keystroke you want, we'll return, dir. And there we go, we got bin, it shows up, it's new, size works. Starting sector does not work, I'm gonna work on that and I'll get back when I find that out. Alright, popping back in for a couple more minutes. I did get a value to show up for starting sector. I think this is correct too, 8 plus 3 is 11, right? And 11 in hexadecimal is B, because 10 is A. So it looks like we got this correct, so that's good. Let me show you what I did there. So under the check file name saving, so I changed this again. I put byte to be more explicit. I don't know if that fixed anything or not, but anyway. We're moving ESDI plus 14, that byte, into AL. That's the starting sector byte in the file table entry. If that's 0, we're going to new file. If it's not 0, then we're going to add the file size in bytes. So if it's not a new file, if there's not a 0 in the starting sector, then we're going to add the 15th offset, the 15th byte offset for the file table entry, which is the last one, which is the file size. We're going to add that to AL. And then we're going to move that to the last save sector variable. So this way it only adds and it only saves the sector for the last one that was found. If it's not found, it's not going to save this. It's going to go on. So new file. So what I was doing before was, since we were at the non-existent file table entry, everything was zeros, so it doesn't matter. AL had 0 from the starting sector and the file size. Since they didn't exist, they were 0. When I moved that into the last save sector down here, it was 0. That's why I was getting a 0 there. So now that that works, I'm just moving it in, only taking it if it's, if it's applicable. We saved it into this variable, so now that it's saved, it gets filled out. So it's pretty nice. Again, I don't have to make here because I already did, but I'll do it again if I can type. See, we have nothing there, we have the editor. So we'll do a new binary file, we'll just do, it doesn't matter, B40, F4. That doesn't do anything, it doesn't really matter, because we're going to erase it anyway. Test, ing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, any key press, and then question mark to go back. And we got testing, we got bin, entry 0, starting sector B, size in sectors is 1. We've got saving to disk partly done. I think it's working okay. Hey, I'm gonna splice in a little minute here before I go to bed. I was having an issue with the editor running regular statements earlier. Actually, executing the hex code, it wasn't working. I had this as move byte DI, so if you just have it as DI, it does not. It's different from entering it into ESDI. Just moving the byte into DI will not really put the full return thing in there, but moving it to ESDI will. But I can show you what I mean. So let's just try it with just moving DI how it is. Let's just try this to print a T. Now normally this should return because I did not put a halt or anything, like F4 to halt. I didn't put that instruction in. It's just print a T and I can't do anything. It doesn't return. The implicit return doesn't work. If we instead move the far return byte to ESDI, it should work. So this will print a T, but it should immediately do a far return, so you won't see the T. And it enters, and you can enter in stuff again. That's a far return. So B40E, B054, CD10. We'll do it once again just to check. And it returns. Okay. Now this will halt and behave as normal, and it'll lock out. But it wasn't working before. You have to change it to ESDI. Or do store string byte. If you can move 0CB hex to AL and then do STOSB to store string byte, because that'll move AL into ESDI, so, or wherever DI is happening to point to. So just wanted to fix that up. I also did this jump back to hex editor instead of reset hex editor or reset editor, because I didn't change that from when we messed with it. But there we go. Then it'll jump back to right here and take the next keybinds and everything. So okay, just wanted to put that in real quick before I went to bed. All right, Jackie, one more thing. So, one more thing to show you. If you didn't see Jackie Chan Adventures as a kid, you can watch that for that reference. But to test if we actually wrote the data to the disk when we're saving by running the save file code, yes, we are. It did work. This is, I just typed in, what I just did to test, print a T and halt. Then I typed in test and, the 6 spaces because that's what I named it. So this is verifying it did write the file table entry. And when I type in the program name, it goes and runs the code here, test, which prints a T and halts. So just wanted to show, yes, our code does work for saving. It might not be fully 100% exactly correct, and we'll have to put in stuff for updating. But for saving a new file and then running it, if you want, it does work. So just wanted to let that be known. But yeah, I'll get the loading file here soon.